Sets 3. All right, the union of two sets. In sets, wherever you see that symbol, it means union. Therefore, this entire statement that I just underlined reads A union B. So, what is A union B? A union B is the set of all elements in the universal set which are either in A or in B or in both A and B. All right, so let's, for argument's sake, let's try and illustrate on this Venn diagram here. U, it's my universal set. This is A and this is B. The element X here is in A. It is clear. The element Y here is in what? B. And the element Z is in both A and B. So anything within this, the A circle is in A. Anything within the B circle is in what? B. A and B overlaps. And Z is in the region where A and B overlaps. So X is in A, Y is in B, and Z is in both A and B. So the region, sorry, A union B is a set of all elements which are either in A or in B or in both A and B. So by definition, this entire region here is A union B. Because if you're somewhere within the shaded region, you're either in A or in B or in both A and B. The shaded region is A union B. All right? And I'm guessing everything that is not A union B would be A union B complement. But as we learned from the previous video, this section is also what? A complement intersect B complement, which you could interpret as being not in A and not in B. All right, let's go ahead and let's go a little further and see what come to. So A union B is a set of all elements in A and B combined. So if you look carefully, you see that this shaded region here is actually the sum total of A and B. So A and B combined together is A union B. Let's have a look at this example. Now in example 2, we're told that the universal set U is a set of counting numbers from 1 to 10. A is the set of even numbers. B is the set of odd numbers. So the first thing we're asked to do is to list, using set notation, the elements of A union B. So remember, you get A union B when you combine A and B together. So if I want the elements of A union B, I need to list all the elements in A and B put together. So it's 1, 2, 3, 5, 7, and 9. So all the elements in A and B together, if I list all the elements of A and B together, I'm listing the elements of A union B. Now let us list the elements of A union B complement. Now A union B complement would be the set of all elements in the universal set which are not in A union B. So when you hear complement, you can think not in. So A union B complement could be interpreted as, you could interpret that as not in A union B. So the elements which are not in A union B are 4, 6, 8, and 10. All right. Let's go a little further. We need to list all the elements of A complement. intersect A complement and B complement. All right, so let's do that. A complement would be all elements which are not in A. A are the prime numbers. Say A complement would be all the numbers which are not the prime numbers, which are like 1, 4, 6, 8, 9, and 10. So those would be the elements of A complement. B complement, B I think are odd numbers. So B complement would be even numbers. So that would be 2, 4, 6, 8, and 10. So next we are asked to list all elements, the elements of A complement union B complement. So when A complement union B complement would be all elements in A complement and B complement together. All right, so let's list all the elements of A complement and B complement together. So A complement union B complement would be 1, 2, 4, 6, 8, 9, and 10. That's A complement union B complement. All right, next you're asked to draw this information, the information which you were given previously. Um, Draw a clearly labeled Venn diagram of the information. So let's remind ourselves of the information. U, counting numbers from 1 to 10. A, prime numbers. B, odd numbers. U, A, B. Elements common to A and B are 3, 5, and 7. So the elements which are in both A and B, we'll put them here in the middle, 3, 5, and 7. Elements in A besides 3, 5, and 7, 2. Those are the elements which are in A only. The elements in B besides 3, 5, and 7 are 1 and 9. Those are the elements in B only. And the elements which are neither in A nor B are the elements 4, 6, 8, and 10. All right, so this is my clearly labeled Venn diagram of the information. All right, we did something like this in the previous video. So here we're looking at either or referencing A union B and neither nor referencing A union B complement and A complement intersect B complement. So here, so universal set, this is A and this is B. If the examiner wants to refer to A union B without saying A union B, the examiner might say elements which are either in A or B. So if an element is either in A or B, that element would be somewhere within the shaded region. If you are somewhere within the shaded region, you are either in A or you are in what? B. So in here is referred to as what? A union, sorry. If you're in here, so if the examiner wants to talk about A union B without saying A union B, he would say either A or B. So if you're out here, you are neither in A nor B. All right. we already identified that the shaded region is A union B, and the region that is not shaded is A union B complement, meaning not in A union B, or A complement intersect B complement, meaning not in A and not in B. All right, let's go a little further. All right, in example 3, in each of the following, we're to label the shaded region using set notation. All right, so sometimes the examiner might ask you to do something like this. He would shade a particular region and ask you to label that region using set notation. All right, here, the shaded region here, we can clearly see that if you're in that region, you're in P and you're in Q. If you're in P, both P and Q, you are in P. You'd be in P intersect Q. So that region there is P intersect Q. P intersect Q is a set of all elements which are in a set of all elements in the universal set which are in both P and Q. Number 2, the region that is not shaded is P intersect Q. So and the region that is shaded is everything that is not P intersect Q. Everything that is not P intersect Q is P intersect Q complement, meaning not in P intersect Q. In 3, if you're in that shaded region, you're either in A or you're either in P or Q. Now, if you're either in P or Q, you're in what? P union Q. 4, in 4, you're neither in P nor Q, or the region that is not shaded, the unshaded region is P union Q. Therefore, the shaded region would be P union Q complement, which means not P union Q. This also has the dual name P complement intersect Q complement. So those two sets, P union Q complement and P complement intersect Q complement, are those two sets are equal sets. All right, 4. If you shade all of P, all you have simply shaded is P. In 5, sorry, if you've shaded all of P, all you have simply shaded is P. In 6, the region that is not shaded, the region that is shaded is the region that is not P. The region that is not P is P complement. All right, and the last 2, and this would bring us to the end of set 3. Let us see over here the shaded region, element X. X is an element of P that is clearly seen. And X is not an element. X is an element in P, but it is not an element in Q. If an element is not in Q, it is in P, Q complement. So the shaded region is both P and Q complement. So therefore, the shaded region is common to P and Q complement. So it is the shaded region is P intersect Q complement. Because once you're common, you know you're dealing with what? With intersect. Over here, the shaded region Y is not in P, therefore it is in P complement. But the shaded region Y is also in Q. So I could say that the shaded region is common to both P and Q complement. Common means intersect. So therefore the shaded region is P complement intersect Q. All right. So this is something that you need to practice to ensure that if you're ever called upon to do this, you would be able to do it without making an error. So that brings us to the end of sets 3.